Constants, Expressions, and Basic Operators, Part 1. Welcome back! In our previous two lessons, we learned about variables and how to write better C++ programs by formatting input and output using count, sin, and escape sequences. Almost every program you write will need to perform calculations, whether you're finding the average of marks, calculating the area of a circle, or computing a total bill. Your program must work with values and perform operations on them. To do this, in addition to variables, we need to understand constants, expressions, and operators. Today we'll begin by learning about constants, expressions, and the basic arithmetic operators. In the next lesson, we'll continue with the remaining operators that are needed before we study control statements. Let's get started. What is a constant? In our previous lessons, we learned about variables. A variable stores a value that can change while the program is running, but sometimes we need a value that should never change. Such a value is called a constant. We can define a constant as follows. A constant is a value that does not change during the execution of a program. For example, the numbers 10, 25, and 3.14 are all constants. The character A is also a constant. The Boolean value true is another constant. Unlike variables, the values of constants remain the same throughout the execution of the program. Types of constants: C++ support several types of constants. The most common types are integer constants, floating point constants, character constants, string constants, and Boolean constants. Let's look at them one by one. Integer constants are whole numbers. Examples include 5, 20, 100, 0, and -15. Notice that integer constants do not contain decimal points. Floating point constants contain decimal values. Examples include 3.14, 5.75, and 0.5. These are used whenever we need decimal numbers. Character constants. Character constants store a single character. They are written inside single quotation marks. Examples include the character A, the character B, and the character 9. Remember that a character constant stores only one character. String constants. A string constant is a sequence of characters enclosed inside double quotation marks. For example, hello and welcome to C++ are string constants. We've already used string constants many times with count. We'll study strings in detail later in this course. Boolean constants. Boolean constants have only two possible values. They are true and false. They are commonly used when making decisions in programs. We'll use them frequently when we learn if statements. Symbolic constants. Sometimes we use the same value many times in a program. Instead of writing the value repeatedly, we can give it a meaningful name. This is called a symbolic constant. Unlike ordinary constants such as 10 or 3.14, symbolic constants have names. This makes programs easier to read and easier to maintain because you can change the value in one place instead of searching through the entire program. There are two common ways to define symbolic constants in C++, using the const keyword. The first method uses the const keyword. Using the const keyword, you can declare a symbolic constant with a specific data type, just as you declare a variable. Once a value is declared using const, it cannot be changed. The example shown on the screen declares a floating point symbolic constant named pi, and assigns it the value 3.14159. Here, pi always stores that value throughout the program. Using the hash-defined preprocessor directive. The second method uses the hash-defined preprocessor directive. Whenever the compiler encounters the defined name, it replaces it with the specified value before the program is compiled. The general format is shown on the screen. It begins with hash define, followed by an identifier and a value. In the example, pi is defined with the value 3.14159.265. Although both methods work, modern C++ generally recommends using the const keyword because it provides better type safety and is easier to debug. What is an expression? Now that we know about constants, let's see how they are used together with variables. Suppose we have two variables named a and b. If we add the value stored in a to the value stored in b, we are asking C++ to perform an addition. This is called an expression. We can define an expression as follows. An expression is a combination of variables, constants, and operators that produces a value. For example, adding two variables, multiplying two numbers, or dividing one value by another are all expressions. Whenever an expression is evaluated, C++ performs the required calculations and produces a result. Expressions are used throughout programming. Every time we calculate a value, compare two values, or make a decision, we are using expressions. What is an operator? Before we look at different operators, let's first understand what an operator is. An operator is a symbol that performs an operation on one or more values. The values on which an operator works are called operands. For example, in the expression where a is added to b, the plus sign is the operator, while a and b are the operands. Today we'll begin with the most common operators called arithmetic operators, which are used to perform mathematical calculations. Arithmetic operators. Arithmetic operators perform basic mathematical operations. The 5 arithmetic operators in C++ are addition, subtraction, multiplication, division, and modulus. Let's look at each one. Addition operator. The addition operator uses the plus sign. It adds two values together. For example, 10 plus 5 equals 15. If a is 10 and b is 5, adding a and b produces the result 15. Subtraction operator. The subtraction operator uses the minus sign. It subtracts one value from another. For example, 20 minus 8 equals 12. If a is 20 and b is 8, subtracting b from a produces the result 12. Multiplication operator. The multiplication operator uses the asterisk symbol. It multiplies two values. For example, 6 multiplied by 4 equals 24. If a is 6 and b is 4, multiplying a by b produces the result 24. Division operator. The division operator uses the forward slash. It divides one value by another. However, there's something important to remember. If both operands are integers, C++ performs integer division. For example, 7 divided by 2 produces the result 3, not 3.5. The decimal part is discarded. If at least one operand is a floating point number, the result includes the decimal part. For example, 7.0 divided by 2 produces 3.5. We'll demonstrate this in our practical session. Modulus operator. The modulus operator uses the percent sign. It returns the remainder after division. For example, 10 modulus 3 equals 1 because 10 divided by 3 leaves a remainder of 1. The modulus operator works only with integer values. It is commonly used to determine whether a number is even or odd. For example, if the remainder after dividing a number by 2 is 0, the number is even. Otherwise, the number is odd. Practical session. Now it's time for our practical session. Let's open Borland C++ and apply what we've just learned. In this example, we'll build a simple calculator program. We'll use variables, symbolic constants, expressions, and arithmetic operators to calculate the sum, difference, product, quotient, and remainder of two numbers. We'll build the program step by step and explain every important line along the way. Let's begin. Live coding. Let's start by creating a new C++ program. First, include the required header file and create the main function. Next, let's create a symbolic constant named version using the const keyword and assign it the value 1. Now declare two integer variables named a and b. Initialize a with 20 and b with 6. Next, display the title Simple Calculator. Then display the program version using the symbolic constant version. Now display the values stored in a and b. Next, calculate and display the sum using the addition operator. Then display the difference. Now display the product. Next, display the quotient. Finally, display the remainder using the modulus operator. Our calculator program is now complete. Let's save the program. Compile the program. There are no errors. Now, let's run it. Notice that the program correctly displays the results of all 5 arithmetic operations. Now let's change the values. Change a to 35 and b to 8. Compile and run the program again. Notice that every result changes automatically. This is one of the advantages of using variables and expressions. Now let's demonstrate integer division. Change the values to 7 and 2. Before we compile and run the program, take a moment to predict the output. Will the quotient be 3 or 3.5? Let's find out. Compile and run the program. Notice that the result of the division is 3, not 3.5. This happens because both operands are integers, so C++ performs integer division and discards the decimal part. Now change the data type of A from integer to floating point and assign it the value 7.0. Compile and run the program again. This time the result becomes 3. .5. Because one of the operands is now a floating point value, C++ performs floating point division. You've now seen how constants, expressions, and arithmetic operators work together in a real C++ program. Challenge yourself. Now it's time to challenge yourself. Take the calculator program we created and try to improve it. Your task is to add a third integer variable named C. Assign any value you like to this new variable, then modify the program so that it calculates and displays the sum of all three numbers. After that, calculate and display their average value. Remember to compile and run your program to check whether the output is correct. Try completing this challenge by yourself before moving on to the next lesson. Summary, let's quickly review what we learned in this lesson. First, we learned what constants are and why they are useful in C++ programs. We explored different types of constants, including integer constants, floating point constants, character constants, string constants, and Boolean constants. We also learned how to create symbolic constants using const and hash define. Using meaningful names for constants helps make our programs easier to read, understand, and maintain. Next, we introduced expressions and learned that expressions combine variables, constants, and operators to produce a value. Finally, we studied the 5 basic arithmetic operators in C++ and applied these concepts by creating a simple calculator program. Next, lesson. In the next lesson, we will continue exploring C++ operators. We will learn about assignment operators, increment and decrement operators, relational operators, logical operators, the conditional operator, typecasting, the size of operator, and we will also have a brief introduction to bitwise operators. These concepts will prepare us to write programs that can make decisions using if statements. Thank you for watching. If you found this lesson helpful, don't forget to like, subscribe, and share this video. I'll see you in the next lesson.